All right, good afternoon. It is Friday, September 30th, 2016. In this video, we're going to be discussing Hurricane Matthew and where he might be going, particularly the long-term effects, the long-range effects. We're going to take an educated guess here. The short-term is actually pretty well agreed on. This right here is the current look of Matthew, and it's very quick. He's very quickly become an impressive-looking hurricane. You can even see a little eye trying to form right over here, just north of the coast of Colombia. That's sitting here about 72 degrees west. It is slowing down, drifting west-southwest, and it should remain over this general area, move into this general area over the next 24 to 48 hours, not moving all that much. But it has rapidly gone from developing a tropical storm just over the Lesser Antilles back over here would be just east off the map, just east of where this image goes, to now a Category 3 with winds of 120 miles an hour already. Pressure is down to the 950s. A Hurricane Hunter plane is in there right now, and it's been dropping pretty much every single time. Finds a new low pressure every time it goes through. So it's somewhere in the 950s right now. It keeps updating, and I'm sure by the time I post this video, it will go down even more. So that's where it's at right now. Some of the models actually have it weakening over the next 24 to 48 hours when it moves into this region because of elevated shear and some dry air. But so far, it has just basically been laughing in the face of the shear that has been over it for the last 24 hours because it has developed pretty rapidly over that time. Let's take a look at where the National Hurricane Center has this going over the next 5 days. They have that general west-southwest motion. Everywhere we have the M symbol is a major hurricane that's a Cat 3 or higher. It turns up toward Jamaica by Monday, possibly making landfall over Jamaica, and then very likely to make landfall somewhere over the eastern half of Cuba. The Hurricane Center weakens it back down to a hurricane after land interaction with Cuba, not necessarily because conditions are going to be unfavorable, but it should hit a bit of a speed bump when it goes over here. But what we're really concerned with, the question everybody wants to know, and the question that we really can't answer right now is, what happens after it emerges into the northern Bahamas, or somewhere in the Bahamas, in the middle of next week? Right now, despite all the chaos, there's actually pretty darn good agreement through day 5, and that's pretty impressive. I know we all want to know where it's going to end up in the real long term, but through day 5, there's a pretty good consensus that we're going to have a hurricane somewhere here in the Bahamas, and I actually think this will be a major hurricane at this point. Assuming it goes in here as a major and there's and you have enough favorable conditions, which it looks like there will be, it should recover at some point in this area and become a major hurricane again if it wasn't entering this, coming off of Cuba anyway. It should weaken some, but I think it has a good chance to gain whatever it loses in here back because conditions are likely going to be favorable when it gets up here. So let's now take a look at our two main models here, the GFS and the European model. Oops, this was the European's 12Z run today, and we can bring this down a little bit more into focus. Here it is right now. It initialized at 976 millibars, so you can see that the storm has already gotten much stronger than the European initialized at. So this may be off. Speaking, you see here it had it weakening, but it's gone the opposite direction. But in general, the track takes it up toward Jamaica by day 3, hooks it slightly northeast or northeast toward Haiti, so it kind of goes over the western edge of Cuba in the short range and brings it up very, very slowly. And what that's going to do is it's going to miss the connection from the trough, which I'll show you here more in the GFS in a second. The trough that's up there, and which means it's just going to kind of sit in the Bahamas, turns towards Miami, becomes a Category 4 hurricane over the Bahamas. This is just a disaster for the Bahamas. I mean, this is now 2, 3, 4 days sitting over the Bahamas as a high-end Cat 4, close to Cat 5 hurricane by the time it gets to the northern end of the chain. And it just kind of sits there as he drifts back south. But literally in 5 days, so this is where it's at day 5 in the Euro, and this is where it's at day 10. So this could be sitting here for almost a week according to the European because it gets trapped down near the bottom. This is the GFS model. Let's show this view here. GFS initialized a little lower, 969 millibars. And it's going to take the same general track, weakens a little bit, see, back into the 970s here, like the Euro. But again, we know the intensity is already probably going to be wrong because Matthew is already in the short range, going the opposite direction. So we already may have a monkey wrench in the equation here. But in any case, like the Euro, it's going to turn to the north, right over here, toward Jamaica. Run across eastern Cuba. It's faster than the Euro. Notice how by day 5, remember the Euro was back down here in the southern Bahamas at day 5. The GFS has it in the northern Bahamas, and that's critical because the GFS is going to run north faster and is going to become a player and is going to get to play with some of the features that are going to be up here, which we'll get to in a moment, and that's going to totally change the outcome. So Matthew then runs north. It develops into a high-end Cat 4, close to Cat 5 hurricane, dangerously close to the Carolina coast here, and then starts to head east. There's a Cat 5 right here at 9:18. That is a huge storm. Starts to head east and then is going to hook north at the last second into the coast of Maine. It looks like it's going out to sea, and then it hooks back to the north, which is quite a solution. So you have the Europeans sitting down here off Miami for 5 days, and the American GFS model goes into Maine. So you have pretty much the entire East Coast in between now tuned into what this thing is going to do. So if we look as to why does this happen, well, if we go and take a look at the 500 millibar pattern, which is going to provide us some answers here. Let's go back to the beginning here. Here's Matthew coming out. We have this upper level low over the Ohio Valley, Southern Great Lakes. And this is going to come out, and what's going to happen on this run that's important. Again, I want to pay attention to this system more than anything else. It's going to get ejected out. You see right over here, it's weakening. There's this little opening right here in the Gulf of Maine, and the GFS ejects that out. And what then that allows to happen is, watch these numbers. The ridge is allowed to build back to the northwest toward the New England coast. Watch these numbers here as we go forward. 579, 582, 585 starts popping up. This is a sign of high pressure and ridging nosing back to the northwest. And this is very, very important because this did not happen in previous GFS runs. The upper level low got trapped here in previous. So this is a previous GFS run where, and if I'll run it forward really, really fast here, where it just goes way out to sea. You can see how it runs. It does not hook back into Maine. It just goes way out. And the reason for this is, if you look on this particular run, you see these lower heights here, this blue shading, and what happens is you see this 576 lower numbers here, so the heights are lower on the previous GFS run, and what that does is it prevents the ridging from building back towards the East Coast. So when the hurricane gets to this area, there's lower heights and a weakness in this area. And when the hurricane gets to that point, it shoots for that opening. And that's why you see this sharp, sharp east turn on the 6Z GFS. But today, the latest runs have trended toward more ridging in this area, which is why you see it get, up to 585 heights all the way to the New England coast. And what that does is it keeps it west longer and allows this feature back over here to grab the storm and pull it back. So notice you have this troughiness here, this becoming negatively tilted trough, which means it's pointed in this direction instead of that. The orientation is pointing in this direction from northwest to southeast instead of what you normally see with a trough where it's northeast to southwest. But if you watch when you play it forward, these blue colors reach out. See how they grab it right there? And now once they grab it, then it's going to turn this back to the north into the Maine coastline. That's the key feature right here. Now, why this is so you got three features so far. There's really four I want to go into. One is the speed of the hurricane. We saw that originally, right? With the GFS coming up here in the northern Bahamas by day 5 and the Euro in the southern Bahamas. That's key number one. If the Euro is right and it's further south, it has a chance to get stuck because there'll be no steering currents down here after day 6. If it's fast like the GFS, it will get up here north of 30 degrees latitude, and then you're going to play with features 2, 3, and 4. The feature number 2 is that upper level low I talked about. Both the Euro and the GFS had the upper level low in there yesterday and last night. Now today, they both kicked it out. That is a very, very significant development. And if that stays, we're going to have to continue to watch it because that can flip-flop back and forth. But if they kick the upper level low out, like I just showed you on the GFS, and you have those heights building back toward the New England coastline, the likelihood that this is going to hit somewhere on the East Coast probably doubles. I don't know exactly what the odds would be. You can place them where you want, but I can tell you that the odds are significantly higher that this is going to end up impacting somebody along the East Coast of the United States if those ridges are allowed to build back toward the coast. Third feature is this piece of energy back over here and this trough. So you have this energy coming back over the plains, And it's weakening, but as it's going negatively tilted, and the one thing about this run, it's really not even that strong, this run, and that's why it's so concerning, because even in a weaker trough, it was still able to reach out and grab the hurricane. There have been runs where this trough was much, much stronger. I think if I can find one back here, you know, if I can go back a couple days ago, they had runs. Here's a run, an example of yesterday afternoon's run. Look how much stronger this trough is here. So if you had a trough this strong when it was in this position, it would be grabbing the hurricane down here and throwing it into, you know, Delaware, New Jersey, New York, maybe Connecticut, you know, one of those places. If you had, but the ridge is weaker. But in yesterday's run, it didn't matter, because the upper level low was still hanging around, and the storm was kicked out to sea. You can see if we play this back again. This is yesterday afternoon's run of the GFS. You had this the remnants of the upper level low, lower heights here down to 579, which creates a weakness northeast of the system, and the system runs out away to the east before this feature can grab it. So this feature is very, very important, feature number 3. We don't know exactly how strong it's going to be, but if this were modeled any stronger and the upper level low continues to get kicked out, instead of landfalling in Maine, you're going to have potentially an even stronger system hitting down here, because it doesn't spend more time, you know, potentially weakening out here over the cooler waters of the North Atlantic. It kind of rides the Gulf Stream and then gets hooked right back into the coast. And the final feature that I'm watching is going to be one you're not even going to be thinking about. It's this stuff coming right off of Japan. And you say, well, why does that matter with a hurricane potentially going into the East Coast? And I'm going to show you why that matters. See if I can pull up the right map here. Yeah, this one right here. So if we look at this feature right here, actually we'll do this second. Let's look at the 500 millibar map before we go in there. So this is the GFS run again today. We'll run it forward. You can see this is the big trough that swings through. This is what will eventually pick up the hurricane here. It runs through, hurricane comes up the coast, and then reaches out, and then grabs the hurricane and brings it up to the coast. But what we also notice here, okay, as we go into the future, is you have another system in the mid-range here coming into the northwest coast of Washington and Oregon. This system right here running in. And if we track this system back, so here we are at 156 hours. If we look at this system, see if I can pull it up here. Right here, the 1002 millibar low coming into the northwest. Look where that originates. If we run it all the way back, so keep watching it back, keep your eye on this system, run it all the way back here. Back to hour 54. It's this very, very weak little stream, and that correlates back to this energy coming off over here, right? And let's see if I can pull back up the right frame here. Okay, so if we put this forward now on 500 millibar, and we look what that does, right? It's this little tiny piece of low. It looks very, very insignificant, and it comes across out over here. It almost disappears. It disappears for a moment, and then it's going to reemerge right there, and then start to blow up. It blows up, tries to connect with what's left over from this trough over here, and runs it into the northwest coast, right? And the reason why this is significant is because if you look at the bottom of the screen, when this is coming in, you have a ridge trying to build over California and Arizona and Utah, and you can see it's trying to see these heights here. There's a little bit of a bulge here. It's trying to reach up. It really wants to. It eventually does. It hooks up with this ridge over Alberta and Saskatchewan, but it's not able to do that as efficiently or as quickly because this system is crashing into the west coast and trying to knock the ridge down. As we saw, it nearly died when it was back over here. If it dies when it's over here, if this stuff that's coming off Japan dies, it's not going to be able to crash into the coast. And if it doesn't crash into the coast, this ridge is much further north. And why is it significant if this ridge here is much further north? Well, all the atmosphere is connected. So if this is further north faster and this gets pushed up, stuff over here is going to get pushed down. And what's over here? our trough, our negatively tilted trough. So if this ridge is bigger, this trough is going to be over the Great Lakes instead of, eastern Manitoba and western Ontario, and it's going to be able to grab the hurricane easier. And that's something that we're going to have to watch. So all for those features, the speed of the hurricane, the upper level low kicking out, the orientation of this trough, and what happens with this system out in the Pacific. Already near 15 minutes, so I'm going to stop there. Very, very interesting situation. Stay tuned.